average. And I'll put that on there too. Well, yeah, but as you're entering, you're watching the numbers go in, you're kind of like, oh, this is interesting. This is a 24. This is a 9. This is a 12. This is a 15. Any overriding patterns coming out at you? Michael, go for it.
Full B is the best, but it's like it changes all the way from 9.9 to 17.
I was nervous about that actually. They weren't skids, nor were they seemingly different lockup controls than the other ones. I thought that the 9, the 12 that was in there, there's a 12 and 12.3. As I was playing this data on Saturday around 1, I thought the exact same thing. Like, wow, 9, holy hell! And I went back and I checked. I said I started at the top at the flower pot, let the brakes up, put the right foot gingerly on the pedal, let it coast down, just 9.9. Very strange, very quick. Especially in comparison with 20s up top, like half the braking distance. But it was just in that one data point, which we can remove if we think we want to later on, which I'm not entirely opposed to. That could have been a fluke, especially because it wasn't replicable. It happened, it was the very last measurement of the day for me, and then Max ran out of energy and patience and wanted to stop doing it. He's 6, for God's sake. I'm surprised he lasted as many as he did. So what do you say? We have one vote for full V looks like the best, mini V maybe second, and then cantilevers come. Remember the conclusion we had last time between these two? Did I make a good call going with these guys?
Wasn't it like 8 feet more stopping?
Something minimally, I think it was, right? If we actually graphed everything and looked, we actually made intervals around them. I like, yes, I like that very much. So yeah, this looked like it was much better than that. So now the question is, how does this play into the mix? How does this play into the mix, right? Andrea's like, oh, shh. Why is he asking me this? Hey, Tim, go.
It looks effective.
It looks effective. So in other words, I'm not losing anything.
15s and 14s.
Oh, good. Thank you, sir. Thank you. So the question is, I'm not losing anything by switching to full V's versus mini V's. Maybe I'm not gaining any. Maybe I am, which Michael's saying. Maybe I'm gaining a little bit of braking distance. Maybe it might be negligible, right? It might be negligible, but maybe I'm getting a little bit. So the question is, what's the best way to decide? What's one thing we can do right now to decide? Think 243. What can we do right now to see if one's better than the other? Any ideas from 243? Simple averages, yes? Simple averages, any standard deviations around the averages? Yes? Let's do that. Let's do that. I mean, you use this.
That's why I gave up.
What's the matter?
I'm still doing it.
You still...
I have a few data point, but I'm not working for it. Oh,
Extra. Okay. So, I got everything in L1, L2, L3. I'll put it up here. Let's zoom.
I'm done if everybody else is. Which means I did one.
Ah, week 10. Gotta love week 10. Tired of pushing buttons. Wait till you see what the button pushes are actually doing in this. All right, there's my average for cantilever, 23 feet. 23 feet. Should I even be looking at the average?
No.
Why?
I don't know.
You thought it was
You should look at the worst.
the worst case scenario? Why?
To protect yourself from
Well, careful. What if that worst case scenario is unusually worse? Maybe that's the one where the brake pad fell off while I was testing it because of the poor mounting. So this goes back to my question. Should I even be looking at the average? How do we decide? Think 243. We're not even going 244 yet. How do you decide if you should use an average or if an average is misleading? When shouldn't you use averages in sample data?
Outliers.
When your sample data is full of outliers and weirdly shaped and skewed to one side, when you've got averages are only well behaved when you've got roughly bell-shaped data. Roughly bell-shaped data. Let's take a look at it, yes? As a matter of fact, you know what? You guys are tired of this. I prepared this for you. I thought you might be tired of this. I'll be happy to email this to you if you want it. There you go.
Of course.
There's some data for you. There's some data for you. I can email this to you if you want it. This is why I want to have the damn class in a computer lab. We could actually design these together, which would be freaking rad. So there's cantilevers, mini V's, full V's. You guys voted we should take out the 14.4.
Yeah.
Okay, cool. I'll take that out right now. 14.4. All right. Now here's the cantilevers. They're over here in pink. Anything up here to the outliers? I mean, if you look at here's the box plot that goes with them too. I can't figure out how to make Excel put a box plot on top of a histogram. I wish it could. but I can't. So we gotta go with separate box plots. Based on that box plot, there's the median. Here's your box, here's your min, or your max and your min. Any outliers based on that box plot? Nope, everything's nice and concise actually. If there were box plots, you'd have a whisker that's way out or way out that way. That's where I start getting nervous about having to worry about outliers. So, no, looks good, looks good. Now Deanne's saying I should use the extreme. I got no problem with that for a safety margin. Matter of fact, engineers will often do that. They'll use the upper or lower, depending on which one is the worst case scenario, for design. Got no problem with that whatsoever. But if I do that across the board, I'll have the same effect as long as my data is well behaved as using the average. So, cantilevers, here's the mini V's. How's the mini V different than the cantilevers?
They're on the side.
Way more precision in the braking. And this was something I noticed riding on trails with my bike. It's almost like I never quite knew what I was like, friggin' Forrest Gump on a bike. I never knew what I was going to get when I grabbed the brake levers. Am I going to stop? Am I going to crash into that tree? Is that boulder going to get? I don't know. So this, I did like this an awful lot more. I did like this. So this is what we looked at last time. And you guys made a notice that since the box plots don't even touch, pretty good argument for statistical significance right there. Pretty good argument for argument. But now I make it worse by throwing in the damn full-size V brakes. Now notice, here's the mini V's back here in green, and behind them in purple are the full-size V's. Notice, everything looks like bell curves. I'm like, oh, this is kind of cool. I wasn't expecting that, but what the hell? I got them. Why not? One more place that bell curves show up braking distances. But I think, Michael, I have to throw out at least one of those values, yes? Look at this thing here. That 9's got to go, doesn't it? I mean, that, for whatever reason, unless I can go back and recreate it and figure out how I stopped at 9.9 feet, which I couldn't. I tried without taking record of it. I ended up skidding all the time. I got tired of wasting rubber off my tires. So unless I can replicate the 9.9, I think it has to go, because I think if we are then using averages with it, it's going to be yarding that average down artificially. So I'm going to toss him. Let's see how that 12 plays out too. He's going to go away. Goodbye.
I'm assuming you're using like a little speedometer on your bike.
No, I'm using gravity, which is the perfect speedometer. I started at the same spot every time, letting the bike go under the force of gravity. As soon as I hit thing, I start applying the brakes.
So were you going slower at that one time?
I was going as fast as I was going each time. I'm assuming gravity is a constant, and I was minimizing as many variables as I could. Whatever speed I was going, I was going.
And what were you doing downhill and just coasting?
Yeah, that driveway I showed you back in the day.
You were
Same
just
driveway.
coasting, you weren't pedaling.
No, start at the flower pot, foot up, brakes off, go. No, pedaling would have
That's what I was
pedaling
saying.
would have been far too much of a pain in the butt.
Okay, that
Obviously, mechanizing the whole system would be the best thing to do, right? Obviously, putting a machine in the driver's seat, it would be. You get way more consistent that way.
You won't say anything.
Depends. If I can work people drive their bikes because it's safer, it's an upfront cost. I think that's a plus. All right, I think I got to toss the 12 too, don't I? That still looks like an outlier. This little guy right here,
Yeah.
he looks like he's an outlier as well, doesn't he? If you look at it, I'm looking at this box plot right now, and this whisker compared to the size, the consistency of that box looks like it's too. Let's get rid of him too. Okay, now I think we're okay. There might be one more, but I think it's combined enough that it's going to be legit. So now, looking at the boxes of the full V's, I like Andrea's precision argument, right? Even if I take that little bit of precision, the box is half as wide. So maybe I'm even getting more concise braking with the full V. Maybe. Again, I don't know. I'd have to measure this quantitatively. Is that fair? Now, how? Now think 244. We've got our data. We've got our touched up. Let's go back into our TIs and chop out the data we don't want. Right? Get rid of that data we just cut. So we cut the 14.4, which I think is already gone. We've got to cut the 12
And the 9.
and the 9. And I think they're right next to each other. It looks like in my spreadsheet anyway. Was it 12.3? Yes?
Yeah.
And the 9.9. What's the next one? I think we're okay with the next one. Because it looks like, again, I'm comparing the whisker also to the histogram. The next ones up are replicants of that 15.9 or that 15 maybe.
It's a 14.2.
Oh, 14.2. Should we lock him off too?
Yeah.
What do you think? 14.2, should he go as well? What, no, leave him in? He's legit? That's control. Okay, good, that's control. That's not that far from 15.9, which is modal. So I'm tempted to leave it in as well. It's in that bar. It's kind of hard to see back there unless I tilt the graph a little more. Let me tilt the graph, 3D rotation. Let's see, perspective. Nope. Yeah, this guy appears pretty steep, so I'm tempted to leave it the way he is. Cool. Fair enough. All right, we got some good data. Right. What do we do with it? I want to know if my V-brakes are better than both the cantilevers and the mini Vs. Now here's a question. You have a tool already to compare just the full Vs to the mini Vs, don't you? You do.
Yeah.
You do. You got it from last week. It would be a 2-sample t-test, wouldn't it? It's a 2-sample t-test, isn't it? Average braking distance for the mini Vs versus the average braking distance for the full-size Vs. Is that fair enough?
Yeah.
It's fair enough. That's it. What happens if I add one more? So let's look at the flow chart again. Look at the flow chart, and you'll see I already have that.
Do we really even have to do that when we already?
You do, and here's why. Hold that thought, Kate. Give me 30 seconds on that if you would. Just 30 seconds. We already had the control case, 2-sample t-test. 2-sample t-test, we looked at ADHD brain volumes versus non-ADHD brain volumes. That kind of thing, that kind of thing. You, on the quiz for last week, which I don't think anybody did, which was the one checking the levels of education between cops in City A versus City B. That kind of thing as well. I don't think anybody did it, but whatever, it's out there. So you have a tool for that. Kate's question is a good one. Why the hell? Say that again. No. Your question is good. You're trying to protect confidence, sister. You're trying to protect confidence. So you're saying, why would I bother even testing these guys if I'm trying to see a difference here? Because generally, you don't do progressive testing like we're doing right now. You wouldn't have tested cantilevers versus mini Vs, then later added in another full-size V-brake and go back and test them all again. Generally, you're going to have them all at once in the beginning. Does that make sense?
Yeah, usually.
Yes!
Don't people progress through life?
No, apples, oranges. I'm not saying we won't progress through life and change studies accordingly. But very often you have a control group and more than one experimental group. I just read one on Adderall and Ritalin, and what they did was they had a control group where the kids were getting placebo. They had Adderall 3 different dosages and Ritalin 2 different dosages. So you had 6 groups all compared to the control group. So you have to compare them to control to make sure whatever effect you're testing, which in this case appears to be the V-ness of the brake, is affected, whether it's mini or full. So I like what you're saying, Kate. You're saying protect confidence. And you would do that if you lopped that off, wouldn't you? You protect confidence. The trick is, how do you test all 3 simultaneously while protecting confidence? And that is a challenge. That is a big challenge because it goes back to the flowchart idea. That now when there's one last test that I want you to see before you get out of here. I want you to see before you get out of here. It's called an ANOVA. Yes. And have you heard it before, JC?
No, just like saying it.
Say that again?
I said no,
Just like saying it, an ANOVA. So this is what's interesting. When you get to, I'll put the flowchart back up. Yeah. And one of the things you have to do on your last exam is find non-parametric alternatives to all these, and that sounds much worse than it actually is. It's not that at all. When you have 3 or more averages, because that's what we're going to be testing now, we're going to be testing averages now. Grab another sheet here. We won't finish this today, we'll at least get it started. Your last in-class hypothesis test. Hey, you might want to grab 2 of those. One for your exam, because your exam needs you to fill one of those out too, yes? So you might want to grab 2. Otherwise, you have to print one off yourself. Unless you've got a couple extras, which is totally fine too. Good. Yeah, set them around. So our last hypothesis together. Very sad. Kind of. Not really sad at all. I'm totally stoked for you guys. Take this crap into the world with you. I'm excited.
What are we doing Wednesday?
We'll probably finish this. I don't think we're going to finish this today because I want to see the mechanics behind it, and the mechanics take some time to kind of fully appreciate. And then Wednesday we'll just finish the test and then call it a day. I mean, I can't imagine this being in class the whole day Wednesday.
Yeah,
I
I
hope
think you
not.
said we were just talking about what we liked and